Good afternoon, everyone. My name is Maria del Ponte Sastui. I'm a professor and researcher in computer science in Quilmes National University and Lifia Research Center in Argentina. Today, I come to share with you a topic of my research, the adaptive gamification for collaborative, location-based collecting systems. This is the agenda for this presentation. Firstly, I need to describe the context of application and the domain's needs. In the second place, I will present a model for this kind of projects, followed by a model of an adaptive gamification approach. After that, I will present a catalog of the adaptive gamification approaches, giving the details of two of them. Then I will describe the evaluation methods and results. Lastly, I will share some further discussions and conclusions. Many collaborative projects require that the people do collecting tasks associated to a location and a timestamp. These collaborative projects are known as collaborative location-based collecting systems, in short, CLCS, that are a particular case of collaborative systems where a community of users collaboratively collect georeferenced data. CLCS frequently require the user to visit a specific location in a specific moment to fulfill the sampling or collecting task. These contributions are known as check-ins, and they have at least three values: the georeferenced location, the timestamp when the task was completed, and the sample data. In some cases, a user's check-in can be considered a contribution if there is a pending collecting task that matches both temporally and spatially, and the check-in corresponds to the required task type. Consider the following example. This is a project that surveys the urban trees population. Its collecting tasks are of three types: to survey a jacaranda tree, an oak tree, or an individual of any other species. The project needs to do some tasks in summer and autumn, and others in winter and spring. Also, the collecting space is organized in a set of smaller areas, as we can see in the picture. Even though the CLCS projects may have another type of challenges, this work analyzes some of them which are related to people engagement with the projects. These are to convene a large number of people, to keep volunteers motivated and making them feel part of the project, to generate a certain desired behavior in people, to achieve a certain level of quality and confidence in the results, to have samples for different people. Gamification is the usage of game elements in non-game contexts and can be applied in collaborative projects as a strategy to attract participants, to sustain participation, and to motivate desired behavior. However, gamification cannot be generalized to all users because of the different user profiles, preferences, and playing styles, and this can change over time, so it needs to be tailored to each one. The gamification approach could be adapted to the community members and also take into account the project's objectives to achieve better participation and sustained user engagement. Although there are many definitions of activity, a general understanding stands out that these are changes in the system's mechanics and representation of information that are visible through the system's behavior. These changes are designed to meet the needs and desires of the users in order to optimize the interaction to achieve a certain quality. Making this definition specific to our domain is to tailor the game elements and mechanics considering both the user's preferences and the collecting objectives of the project. In their work, Lee and Park described approaches for tailored gamification ranging from microadaptive to macroadaptive, where the macroadaptive approach allows different alternatives of game versions according to models of the player's stereotypes, and the microadaptive approach diagnoses the player's specific needs or preferences during gameplay and provides tailored gamification for the needs. On the other hand, as a result of the literature review about adaptive gamification, We defined a taxonomy of adaptive gamification strategies that sets two main categories: the adaptation of a single game element and the fuzzy adaptation. The first category can be seen as a micro adaptation over a single game element. For instance, adapting the mechanics of the points reward system to the user profile, or building tailored components such as guidance messages or challenges. A fuzzy adaptation is an adaptation that cannot be associated with a single game element. Even though the project may have other objectives, this work focuses on reaching a target sampling quality level. This is to convene users to do some task in a particular area at a specific time that satisfies a project need. The objectives can be defined as a set of collecting tasks that can be solved, as I mentioned before, by the user's check-ins. Given that each task is expressed by means of a task type, an area where it should be done, and an interval when it should happen, to specify the collecting tasks, a set of geographic areas, a set of temporal restrictions, and a set of task types must be defined. In our example project, we have 6 collecting areas and 2 intervals, and the task can be of 3 types. Given these configurations, I mean areas, intervals, and type of task, the CLCS project objectives can be expressed as a list of collecting tasks. The order in the list allows for establishing some priority to the task. In the example, the most relevant task is to survey a jacaranda tree in area A1 during summer. The progress over the project's objectives is related to reducing the list while people contributes. The gamification model considered in this article has a point reward system, a badge reward system, and a leaderboard as its main design elements. The game is based on the presented model for CLCS. This means that the community of users must perform check-ins that may count towards completing collecting tasks. When check-ins contribute to these objectives, the user progresses also in the game. The game model is a tuple composed of the set of user profiles, the ordered list of collecting tasks, the set of point values, the set of badges, a function for point-based rewards, a function for badge-based rewards, a function that builds the leaderboard, and the winning function. The system must be able to, given a new check-in, assign new points and possibly new badges if it happens that the user's profile has the necessary prerequisites and the check-in satisfies particular conditions. The corresponding game mechanics compute the rewards and leaderboard, taking the pending task list, the badge set, and the point set as parameters. Translating the adaptation definition into the presented game model, its adaptation can be considered altering some of the game elements. Adaptation can be approached through different strategies that involve either a component adaptation or a mechanic adaptation. CLCS adaptive gamification strategies range from ordering and filtering the set of collecting tasks to changing the rules to obtain points and badges. This section presents 6 different approaches to the adaptation of components and 3 different mechanics adaptations for the defined CLCS game model. The 9 strategies are summarized in the table, and I will describe in detail 2 of them by means of an ad hoc defined Python language defined to describe the adaptation strategies for this game model. This language is inspired by the language presented by Alexander and other subsequent proposals for game design patterns. Some fields were added. The model parameters field lists the game model components involved in each adaptation. The type of change field describes how the adaptation is perceived, whether it is through a change in the rules, in the components, or in how the game is viewed. Lastly, there is a scope field used to indicate whether the adaptation is visible to the individual player, affects a group of players, or the entire player community. The intent of the collecting task recommendation strategy is to recommend collecting tasks aligned with the user preferences and project objectives. This is approached with a multi-criteria recommendation system, considering two sets of criteria. The user criteria, including the task area, interval, and contribution type, and the project criteria, considering the task priorities. The game element on which this adaptation is made is the task list. The intent of the elastic rewarding strategy is to use the point reward systems to balance community participation. Of course, the game element on which the adaptation is made is the point reward function. The adapted version of this function is based on its unadapted version and applies to it a scaling factor representing the weight of the contribution in the current context or state of the game. The evaluation of the adaptive gamification approach is done with two devices. On the one hand, a gameful design evaluation, and on the other hand, a player experience evaluation. The evaluation should consider the relationship between the implemented motivational affordances, the psychological outcomes, and the subsequent effects on behavior. This means that gamification system faces two types of challenges at the same time. On the one hand, to reach instrumental outcomes, and on the other hand, affording a desired experience. This is why the evaluation method includes a gameful design evaluation through expert inspection and a playability and player experience evaluation with real users. Tondelo et al. Propose a method for evaluating gamified systems using heuristics from the perspective of intrinsic and extrinsic motivational affordances. They aim to promote the early detection of gaps in system design by organizing this heuristic into three categories and 12 dimensions. Experts use heuristic evaluation to identify usability problems in an existing design as part of an iterative process. For experts in UX, carry out these evaluation processes based on a functional description of the approach. Regarding the intrinsic motivation, what requires more work is related to the challenge and competence dimension. In particular, this dimension analyzes whether the activities have increasing complexity and whether the system has the possibility for players to create their own challenges. Regarding the extrinsic motivation, the ownership and rewards dimension could be exploited more, for example, by incorporating a virtual economy system. Finally, regarding context-dependent heuristics, the dimension with the least compliance is feedback. The presented game model does not indicate per se a guidance mechanism for the person to generate a game strategy. The adaptive gamification approach is evaluated by contrasting two scenarios, the unadapted and the adaptive gamification system. In this case, the elastic rewarding strategy was chosen. The playability evaluation method proposed by Salazar was partially applied to evaluate the perceived game experience in both scenarios. This method includes a gaming personality assessment that is related to the game adoption values obtained after the experience, and a playability facets evaluation through a second survey about the game experience. The survey showed a much greater link with technology and games among the population participating in the unadapted scenario, considering that it shows higher values of familiarity, importance, and time of use. About the pliability assessment, it can be seen that people in the adaptive scenario expressed a greater acceptance than people in the unadapted scenario. Concerning the different facets of playability, the average value of 9 facets can be seen in the figure, which indicates slightly better results in the adaptive scenario. Even that there is a place for badges, points, and leaderboards, The right tool for each case must be selected, and often this will require trial and error. This experiment is the first test that allowed, on the one hand, to gather information on design recommendation based on expert inspection, and on the other hand, to show the applicability of the gamification and adaptation model. As for expert recommendations and player opinions, the improvements that apply to the PBL framework should be considered. While the results obtained through the adaptive scenario are not visibly better, they show that adaptation did not negatively impact over gamification. This article contributes with a description of adaptation dimensions, a gamification model based on points, badges, and leaderboard framework, an adaptation model based on this game model, a set of 9 adaptation approaches, and an evaluation method considering an expert inspection for game design evaluation and a player experience evaluation. Thank you very much for listening. I will appreciate your questions and comments.